Hi, welcome to my second video in this tutorial. In this video, I am going to solve the example and exercise sums of 1.1. I always advise you to have a copy of textbook with you, so it will be very useful to you. It will be easy to follow for you. First, I will start with example 1.1. Example 1.1. Find the number of subsets. Find the number of subsets of A if A is equal to set of all x such that x is equal to 4n plus 1, 2 is less than or equal to n is less than or equal to 5, n belongs to natural number. We already saw in the previous class, if a set has n elements, then the number of subsets can be formed is 2 power n. So first I want to find the number of elements in A, then I want to raise the power 2 to find the number of subsets. Solution. First I want to find the number of elements in A. It is given that n varies from 2 to 5. So when n is equal to 2, x is equal to what? X is equal to 4n plus 1. So this will be 2 into 2 plus 1. So it will be 4 into 2 plus 1, it will be 9. When n is equal to 3, x is equal to 4 into 3 plus 1, this will be 13. When n is equal to 4, x is equal to 4 into 4 plus 1, this will be 17. When n is equal to 5, x is equal to 4 into 5 plus 1, this is 21. So A as 9, 13, 17, 21. So there are 4 elements in this set. So the cardinality of A is 4. We know that if n of A, that is the cardinality of A is n, then the cardinality of power set of A is 2 power n, which we discussed in the previous class. So here the cardinality of A is 4, since there are 4 elements. So the number of elements in the power set of A is 2 power 4. So answer is 16. Clear? Now I'm going to move on. I'm going a little fast. Example 1.2. Example 1.2. Since the question is larger, so I already wrote the question in another paper. In a survey of 5,000 persons in a town, it was found that 45% of persons knows language A, 25% knows language B, 10% knows language C, 5% knows language A and B, 4% knows language B and C, 4% knows language A and C. If 3% knows all 3 languages, find the number of persons who knows only language A. Now I am going to solve this problem using the Venn diagram. So I take this as A, take this as B, take this as C. So A, B and C. Total number of persons is 5,000. So total number of persons is 5,000. I'm going to do this. I'm not going to convert this percentage to numbers. I'm going to solve this sum using the percentage. It is given that 45% knows language A. So the number of person who knows language A is 45%. So 45. The number of person who knows language A. The number of 25% knows language B. So number of person who knows language B is 25. 10% knows language C. So the number of person who knows language C is 10. 5% knows language A and B. So the intersection of A and B is this part, this part, this part. So 5% knows language A and B. 4% knows language B and C. So the intersection is this part. It is 4%. And again 4% knows language A and C. So this is the intersection part of A and C. 3% knows all three languages. Now find the number of persons who knows only language A. Now what we want to find? We want to find this area. It is number of persons who knows only language A. We want to find this only this area. So what I want to do now, I want to find this area. For that, first I want to subtract this. I want to find the number of students who knows only language A and B. Number of persons who know only language A and B is 5 minus 3 is 2. Then the number of persons who knows only language A and C is 4 minus 3 is 1. Then the number of students who knows language, number of persons who knows only language B and C is 4 minus 3 is 1. So I want to subtract this part and this part to find the value of this part. So the number of persons, so the number of persons who knows only A is 45 minus this part is 2, this part is 3, this part is 1. So 2 plus 3 plus 1. So 45 minus 6, 39. It is in all numbers are in percentage, so it is percentage. Suppose if I want to convert percentage to number, is what I want to do. I want to multiply, since there are 5000 students, so we have 5000 into 39 by 100. This 2 will cancel, so we will have 50 into 39. So the answer is 1950. Clear? Now we are going to move to the next sum. First I want to write two formulas which will be useful for you. Formula. The first one, n of A can be written as n of A minus B plus n of A intersection B. N of A union B is equal to n of A plus n of B minus n of A intersection B. Now I'm going straightly to example 1.3. Example 1.4 rather. 1.3 is very simple. You can do this by Venn diagram. I give the integral at the last. So I'm going to example 1.4. If x is equal to 1, 2, 3 up to 10 and A is equal to 1, 2, 3, 4, 5, find the number of sets B contained in X such that A minus B should be a singleton 4. Solution. Now I'm going to consider a subset C. For every subset C of 6, 7, 8, 9, 10, let B is equal to C union 6, 7, in fact I should say C union 1, 2, 3, 5. I'm just omitting 4 here. So B will be 6, 7, 8, 9, 10 union 1, 2, 3, 5. So this will be 1, 2, 3, 5, 6, 7, 8, 9 and 10. So what will be A minus B? A is 1, 2, 3, 4, 5 minus B 1, 2, 3, 5, 6, 7, 8, 9, 10. So A minus B is 1, 1, 2, 2, 3, 3, 5, 5. So it will be only the element which are present in A. So A minus B is 4. We see that the number of subsets of 6, 7, 8, 9, 10 are the same. So we can form from this different kinds of subset, so that A minus B is 4. The number of elements in this is 1, 2, 3, 4, 5. So the number of subsets can be formed with A minus B is a singleton 4 is 2 power 5. So it is 32. Clear? I'm going to move to example 1.5. Example 1.5. If A and B are two sets, so that n of B minus A is equal to 2n A minus B is equal to 4n A intersection B, and if n of A union B is equal to 14, then find n of power set of A. Solution: in order to find n of P of A, first I want to find first n of A. If I find n of A, if I want to find n of P of A, I just want to raise the power to 2, that is 2 power n. So suppose if there are 4 elements in n of A, n of P of A will be 2 power 4. First I want to find n of A. I already given a formula, two formulas. The first formula I gave is n of A is equal to n of A minus B plus n of A intersection B. In order to find n of A, I need n of A minus B and n of A intersection B. So first I want to find these two. If I find these two, then I'll add this 2 to find n of A, and then 2 power this answer will give the n of P of A. So I'm going to find n of A minus B and n of A intersection B. Let I'm going to assume n of A intersection B is equal to K. I'm going to assume this. Since these three are equal, this one is equal to this and this one is equal to this. So n of B minus A is equal to 4n A intersection B, and 2n A minus B is equal to 4n A intersection B. Since n of A intersection B is K, this will become n of B minus A is equal to 4 times K. Since n of A intersection B is K, this will become 2n A minus B is equal to 4K. 2 ones are 2 twos are. So n of A minus B is 2K. So what I have now, n of A is n of A minus B plus n of A intersection B. N of A minus B is 2K. N of A intersection B is K plus K. So it will be 3K. It will be 3K. It will be 3K. Now, if I find the value of k, the answer will be over. How can I find the value of k? Very simple. It is given that n of A union B is equal to 14. N of A union B is equal to 14. N of A union B, a formula which is we have seen several properties. From that we can find n of A union B. N of A union B is n of A minus B plus n of B minus A plus n of A intersection B is equal to 14. N of A minus B is 2k, n of B minus A is 4k, n of A intersection B is k, which is assumed earlier, is equal to 14. So this will be summon k is equal to 14. This implies k is equal to 2. If I substitute k is equal to 2 here, n of A will be 3 into 2, which is 6. So n of A is 6. So n of P of A. So therefore n of P of A is equal to 2 power 6. N of P of A will be 2 power 6, which is 64. Now example 1.6. Two sets have m and k elements if the total number of subsets of the first set is 112 more than that of second set. Find the values of m and k. It's very simple problem, very easy. Solution: two sets have m and k elements. Suppose we have two sets, that set has m and k elements. If the total number of subsets of the first set is 112 more than that of second set, so it is clear that the first set is larger than the second set. Let the number of elements in the first set, let A and B be two sets. Let A and B be two sets. A and B be two sets. Let n of A, that is the first set, as m elements and n of B as k elements. It is clear that from the question, the first set has more element than the second set. It is clear that m is always greater than k. And it is given that the total number of subsets of the first set is 112 more than that of second set. Is 100. So the difference between the two sets is 112. So it is given the subsets. So 2 power m minus 2 power k is 112. The difference between the two subsets is 112. And since m is larger than k, I have written 2 power m minus 2 power k is equal to 112. From this, it's very simple. I am going to factorize 112. 2 times 56, 2 times 28, 2 times 14, 2 times 14, 2 times 7, 7 times 1. So this will be 2 times 2 power 4 into 7. So we have 2 power m minus 2 power k. 2 power m minus 2 power k is equal to 2 power 4 into 7. Now I am going to divide this by 2 power k. I am going to take 2 power k common. So 2 power m by 2 power k, since there is no 2 power k here, this will be 1. 2 power 4 into 7. So this will be 2 power k into 2 power m minus k. I am just raising the power. minus 1 is equal to 2 power 4 into 7. Since these two are equal, the first and first are equal and second are equal. I am going to compare this one. So 2 power k is equal to 2 power 4 and 2 power m minus k minus 1 is equal to 7. So from this it clear that k is equal to 4. Here 2 power m minus k is equal to 7 plus 1, which is 8. I can write 8 as 2 power 3. So from here it is clear that m minus k is equal to 3. Since k is 4, m is equal to 7. So we have found m and k, two sets. Find the values of m and k. So m is 7 and k is 4. Now moving to example 1.7. Example 1.7. N of a is 10. N of a intersection b is 3. Find n of a intersection b whole dash intersection a. It's very easy one. Solution. First I am going to find n a intersection b whole dash intersection a, which is same as a dash union b dash intersection a. Then I am applying a De Morgan's law. It is a dash intersection a union b dash intersection a. A dash intersection a is always empty. Union b dash intersection a. Empty set union this is always with this set. So b dash intersection a. So b dash intersection a is nothing but a minus b. So we have n of a intersection b whole dash intersection a is equal to n of a minus b. I am just applying n to both sides. We already know n of a is equal to, which we saw in the previous problem, n of a is equal to n of a minus b plus n of a intersection b. So from here n of a minus b is equal to n of a minus n of a intersection b. So I apply here n of a minus n of a intersection b. It is given that n of a is 10, n of a intersection b is 3. So 10 minus 3 is 7. Example 1.8. Example 1.8. A is equal to 1, 2, 3, 4. B is equal to 3, 4, 5, 6. Find n of A union B n of A union B into A intersection B into A delta B. It's very simple. First you want to find n of A. It is clear that n of A union B into A intersection B into A delta B is equal to, I can multiply n here, which I can refer this in previous class, n of A union B into n of A intersection B into n of A delta B. First find n A union B and find the number of elements in A union B. Find A intersection B, then find the number of elements in A intersection B, then find A delta B. A delta B is nothing but A union B, A minus B union B minus A, or A delta B is first A union B. A union B is 1, 2, 3, 4. 1, 2, 3, 4. 3 4 already is there. So 5, 6. So n of A union B is 6. Since there are 6 elements, and A intersection B. A intersection B is 3 4 3 4 are there, so there are 2 elements. So n of A intersection B is 2. Then I want to find A delta B. A delta B. A delta B is nothing but A delta B. A minus B union B minus A. So I want to find A minus B union B minus A. What is A minus B? First you want to cancel the B. 3 and 4 are here. So A minus B will be only 1 and 2. A minus B is 1 and 2. Then find B minus A. Then cancel the terms which are in A. So 3 4 are there. So only 5 and 6 are there in B. So n of A delta B. N of A delta B is n of A minus B union n of B minus A. So there are 4 elements in this. So we have n of A delta B. N of A delta B is 4. We have already found n of A union B and n of A intersection B. So you want to multiply these 3. So 6 into 2 is 12. 12 into 4 is 48. So answer is 48. Just substitute these 3 values in this formula. This is the formula. So 6 into 2 into 4. So answer is 48. The last example. Example 1.9. If P of A denotes the power set of A, then find n of P of in fact there is no n here. P of empty set. The empty set has 0 elements. It's very note down, it is very careful. The empty set has 0 elements, but a singleton set has 1 element. So the number of elements in empty set is 0. So the number of subsets can be formed is 2 power 0. So if I take a set A is equal to empty, then n of A is 0, since there are 0 elements in this set. So how many subsets I can form? P of A, that is P of empty is equal to 2 power 0 is 1. So the answer for this is 1. Again I want to apply the power set. So P of empty is 1. So we have 2 power 1 is 2. So the answer for this is 2. Again I want to apply P of 2. So P of empty set, the answer for this is 2. So this is 2 power 2. So the answer for example 1.9 is 4. That's 4 elements. 4 elements are there. Now I'm moving to exercise problems. Exercise 1.1. The first is write the following in roster form. Roster form is nothing but the number representation of set. So the set will be like this, it will be of numbers. The first one is set of all x in natural number such that x squared is less than 121 and x is a prime. So x is a prime, very simple. It is given that x squared is less than 121. I can write this as x squared is less than 11 square. So this implies x should be less than 11. So the possible values of x are 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Among these, it is given that x should be a prime. So here 1 is a prime, 5 is a prime, and 7 is a prime. So the set of all 2 is a prime. So the answer is 2, 3, 5, 7. We are neglecting the 4, 6, 8, 9, 10 because these numbers are not primes. Second, the set of all positive roots of the equation x minus 1, x plus 1 and 2 x square minus 1 into 0. The roots are nothing but for what values of x the equation will be 0 are called the roots. x க்கு நம்ம எந்த வேல்யூ போட்டா இந்த நம்பர் 0 ஆகுமோ அதான் நம்மளுக்கு ரூட்னு சொல்லுவோம். நம்ம இப்போ இந்த x ஸ்கொயர் மைனஸ் 1 நம்ம என்ன பண்ணிக்கலாம், x plus 1 into x minus 1 எழுதிக்கலாம். because a square minus b square is a plus b into a minus b. So I can write this term as x minus 1 x plus 1. This is x minus 1 and x plus 1 again. So for what values of x, this equation will be 0. If x is equal to 1, this will be 0. If x is equal to minus 1, this will be 0. Again, when x is equal to 1, this will be 0. And x is equal to minus 1, this will be 0. So the possible roots of this equation are minus 1 and 1. Clear? But in the question is given that it should be a positive root. So the answer will be only 1 is positive, minus 1 is negative. So the answers are just a singleton one, because 1 is a positive here. So the answer for this is 2, 3, 5, 7, and for this is 1. The third problem is set of all x in n such that 4x plus 9 is 52. 4x plus 9 is 52. It's very simple. You can try this in your own. It is given that 4x plus 9 is less than 52. So 4x is less than 52 minus 9. I'm just taking 9 to that side. So 4x will be less than 43. So x is less than 43 by 4. X is less than 43 by 4 and x belongs to natural number. So x should be, so what are the possible values of x? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are the possible values of x. These are the multiples of 4 less than 40. The next multiple is 11. So 4 into 11 is 44. 44 is not here. So these are the elements. The next the last problem. B is equal to set of all x such that x minus 4 by x plus 2 is equal to 3. X belongs to real number minus 2. Here they are stating this condition because if x is equal to minus 2, this term will be not what? It is indeterminate, because anything by 0 will be infinity. So just they are neglecting the minus 2 term here. So x minus 4 by x plus 2 is equal to 3. We want to just solve it. X minus 4 is equal to 3 times x plus 2. Just take that, multiply that side. So x minus 4 is 3x plus 6. Multiply 3x into 2. So we have 2x is equal to minus 10 and x is equal to minus 5. So bring the term x here. It will be 3x minus x. Take plus 6 to that side. It will be minus 6. So minus 6 minus 4 is minus 10. So x is equal to 5. So if these are the only term, this is the only value of x for which this condition is satisfied, you can check here. Minus 4, minus 5, minus 4, minus 5, minus 4, by minus 5 plus 2, minus 9 by minus 3, which is 3. So this is the value of x. So x is equal to minus 5. The second one, write the set minus 1 comma 1 in set builder form. Set builder form. So from the first problem we have wrote set builder form to roster form. Now they are given the roster form here. I want to write this in terms of set builder form. So I can write in many ways. You can also try in different own ways. I'm just writing here a is minus 1 comma 1. I can write a is equal to set of all x in R such that x is a root of x square minus 1 is equal to 0. For what values of x, this will be 0. See, so if I put 1 square minus 1 is 0. If I put minus 1, again minus 1 square is plus 1. So plus 1 minus 1 is again 0. So I can write the set builder form like this. The third one, state whether the following sets are finite or infinite. Very simple. The set is countable, or the set ends, we can say the set is finite. If the set is never end, we can say that the set is infinite. The first is state whether the sets are finite or infinite. The first, set of all x in natural number such that x is an even prime number. So the set of all prime numbers are 2, 3, 5, 7, 11, 13, 17 and goes on. Among these there is only one number which is even, so that is 2. Since this is finite, so answer for this is finite. The second one, the set of all x in n, x is an odd prime number. So there are a lot of numbers which are odd here. So except 2, all prime numbers are odd numbers. So the set consists of 3, 5, 7, 11, 13, 17 and goes on. So it is infinite. Set of all x in integer z such that x is even and less than 10. So the number less than, it should be less than 10 and it should be even. So x consists of 2, 4, 6, 8. 10 cannot be added here because it is strictly less than. So it is finite since there are only 4 elements. 4. Set of all x in n such that x is a rational number. X is a rational number. Clearly it is an what I want to write, R. Rational numbers are what? 1 by 2, 1 by 3, anything of the numbers of the form v by q. Since there are so many terms are like that, it is infinite. Again, if you replace this real number by natural number, again it is an infinite set. Again it is an infinite set. For the fourth problem, I am just going to give the values of a, b and c so that you can try it yourself. By taking the suitable values of a, b and c, verify the following results. I'm just going to quote the values of a, b and c so that you can verify it yourself. So take a is 1, 2, 3, b is 2, 3, 4, c is 4, 5 take u is equal to 1 2 3 4 5 6 7 and take b dash is equal to 1 5 6 7. So the help of these 5 sets, refer these 4 problems are there. It's very simple. It's a 10th class. In 10th class I already learned how to add union, differences and intersection. So try it in your own. I'm going to move to the next problem. Justify the truthness of the statement justify the truthness of the statement an element of a set can never be a subset of itself. It's a very easy fact. So take A is equal to 1 and 2. Its elements are 1 and 2. So there are 2 elements in this set. Whereas the subsets of A are 1 2 1 2 and empty set. So there are 4 subsets. It should be 4 because the number of elements is 2. So the number of possible subsets are 2 power 2, which is nothing but 4. Thus neither element 1 nor 2 of A is a subset of A. இப்போ நம்ம இங்கே என்ன சொல்ல வராங்க அப்படின்னா, இப்போ ஒரு செட்டில் 2 எலமெண்ட் இருக்குது, 1 and 2. இந்த 1ஏ சப்செட்டாக இருக்குமா இல்லை 2ஏ சப்செட்டாக இருக்குமான்னு கேட்குறாங்க. ஆனால் இங்கே ரெண்டுக்கும் ஒரு டிஃப்ரென்ஸ் இருக்குது. இது சிங்கிள்டன் 1, இது எலமெண்ட் 1. ஸோ இட் இஸ் நாட் சேம். த சிங்கிள்டன் 1 and the element 1 is not same. So the elements are 1 and 2. An element of a set can never be a subset of itself because it is true. Because 1 is not subset here. There is a difference between the element 1 and then single set being singleton 1. So the statement is true. Now I'm going to the next problem number 6. Problem number 6. N of P of A is 1024. N of A union B is 15. N of P of B is 32. Find N of A intersection B. We know that, which I wrote earlier, N of A union B solution. N of A union B is N of A plus N of B minus N of A intersection B. So if N of A union B is given, so it is 15 here. If I find N of A and N of B, I can find N of A intersection B. To find N of A and N of B, they are given a hint that N of P of A is 1024 and N of P of B is 32. First I am going to find N of A and N of B. It is given that N of P of A is 1024. So 2 power N of B is 1024 because it's a power set. The number of elements in the power set is 2 power of number of elements in this set. So 2 power N of B. I can write 1024 as 2 power N of A is equal to 2 power 10. 2 power 10 is 1024. Comparing this, we have N of A is equal to 10. Similarly, given that N of P of B is 32, here 2 power N of B is 32. I can write as 2 power 5. So N of B is equal to 5. So I found N of A and N of B. I'm just going to substitute in this formula. N of A union B is 15. N of A is 10. N of B is 5 minus N of A intersection B. So take this to that side, take this to this side. N of A intersection B is equal to 10 plus 5 minus 15. So it will be 0. So there is only an empty set. So N of A intersection B is empty. So the number of elements in set is 0. It means that the set is an empty set. So N of A intersection B is just an empty set, or you can denote this by this. The seventh problem. N of A intersection B is 3. N of A union B is 10. Find N of P of A delta B. First we find A delta B. A delta B is nothing but N of A union B minus N of A intersection B. So N of A union B is 3 minus, in fact, N of A union B, in fact it is 3. N of A union B is 10, it is 3, so it will be 7. So A delta B is 7. The number of elements for set of A is 2 power 7. So N of A delta B is equal to 2 power 7, which is 128. Now I am going to move to 9th sum. If I do 9th sum, you can do 8th sum in your own. It is given that A and B be two sets. A and B be two sets. N of A is 3. N of B is 2. If x, 1, y, 2, z, 1 are in A cross B, find A and B. Find A and B. We know that A cross B is a Cartesian product, that is set of all A, B, as that A belongs to A and B belongs to B. It is clear that the N of A consists of only 3 elements and N of B consists of 2 elements. So it is given that x, 1 belongs to A cross B. X, 1 belongs to A cross B. So from the definition it is clear that x belongs to A and 1 belongs to B, and y, 2 belongs to A cross B. So this implies y belongs to A and 2 belongs to B, because A belongs to A and B belongs to B. So from here y belongs to A and y belongs to A and 2 belongs to B, and z, 1 belongs to A cross B. This implies z belongs to A and 1 belongs to B. Since there are only 3 elements, so these are 3 elements in A and these are the 2 elements in B. So A is x, y, z and B is 1, 2. So these are the 2 sets which have the Cartesian product x, 1, y, 2 and z, 1. So the last problem in this exercise, from this problem we are going to wind up this class. If A cross A has 16 elements, and S is equal to set of all A, B belongs to A cross A with A less than B, minus 1, 2 and 0, 1 are 2 elements of S, then find the remaining elements of S. Solution: A cross A has 16 elements, so N of A cross A is 16. It denotes N of A into N of A is 16. So n of a will be 4 times 4 is equal to 16. So we want to multiply two same numbers. The answer should be 16, which is possible only if n of a is 4. So 4 into 4 is 16. It given that minus 1 comma 2 belongs to a cross a. So this implies minus 1 belongs to a and 2 belongs to a. So minus 1 comma 2 belongs to a and 0 comma 1 belongs to a cross a. This denotes 0 and 1 both belongs to a. So a will be of, since there are only 4 elements in n of a, so that 4 elements are 0, minus 1, 0, 1, 2. So these are the 4 elements. Then you can find it very easily. Then you find all the combinations of Cartesian product. So it will be n of a is 4 here. So the number of elements in Cartesian product is n of a and n of a. There are 16 elements in the Cartesian product. First take minus 1 and then pair with itself and 0, 1 and 2. First take minus 1 and pair it with minus 1 comma 0, minus 1 comma 1, minus 1 comma 2. I have taken minus 1 and I pair that with all the 4 elements, and take 0 and pair it with all the 4 elements including itself. So 0, 0, 0, 1 and 0, 2. Then take 1 and pair it with all the elements. So 1 comma minus 1, 1 comma 0 and 1 comma 1 and 1 comma 2, and then take 2 and pair it with all the elements. So we have 2 comma minus 1, 2 comma 1 and 2 itself, 2 comma 2. What's the question? Then find the remaining elements of S. So these are the sets of A cross A. Out of these ordered pairs, the S consists of set of all A comma B such that A should be less than B. The first number should be less than the second number. When you look at this, these two are equal. So among these S is equal to, and just write minus 1 comma 0, minus 1 comma 1, minus 1 comma 2, 0 comma 1, 0 comma 2 and 1 comma 2. These the elements are in S, because when you look at this, A is less than B, because minus 1 less than 0, minus 1 less than 1, minus 1 less than 2. From this, among these are the elements which are the first term less than the second term. So the remaining elements are the other elements, that is the other elements of S are, find the remaining elements of S, minus 1 comma 0, minus 1 comma 1, 0 comma 2 and 1 comma 2. Because these two are already here, minus 1 comma 2 and 0 comma 1. So other elements of S are 1, 2, 3, 4. These 4 elements are written here. So from this we finished exercise 1.1. In the next class I'll begin the introduction to exercise number 1.2 and then I solve the problems. Hope you understand. Please subscribe for latest notification. If you want my notes for this, you want a photocopy of these papers, you just comment it, I'll send it in private. So please do subscribe and like if you understand the video fully. Thank you. We will see you in next class. Have a nice day.